Hi, in this video I'm gonna show you guys one example about intersection point of two vectors. Okay, so let's just kind of go over the overall big picture, right, of what this type of question is about. So today, say for example, I have this typical XY plane, and I have a line that goes like this, just a blue line goes like that. Let's call this line L, and I have another line that goes over maybe somewhere here, maybe somewhere there. Let me call that line M. Now, where is the point of intersection? The point of intersection is here, right? This point right there. So the point of intersection is where these two lines meet. And right now, the point of intersection is 3 and 5. So at that point of intersection, both of my line L and my line M, they have the same x coordinate and the same y coordinate. Does that make sense? Because they cut each other at that point, so they will share the same x and the same y, right? So this is not really something new. It's sort of like a overall review, like a concept, the concept behind intersection points. Now, this line L and line M here, they are not really vectors, right? They are just two lines on a typical XY plane. But if I apply the same concept on vectors, they will give me the same thing. So here's a very typical example of two vectors they intersect each other, they cut each other, and they want us to find the coordinates of the point, where the point of intersection, right? So this is my first line. My first line has a vector equation of R1 equal to 3, 0, 1. That's my position vector, plus some scalar S multiplied by 1, 1, 1. So this 1, 1, 1 kind of give us a direction of the vector of this straight line, right? My line 2 has a position vector of 6, 2, 0, 6, 2, 0, and then plus some scalar T multiplied by some direction vector of 0, 4, 8. Now these two lines are going to cut each other, and they want us to find the coordinates where that happens. So again, let me change the color. So if they're going to cut each other, that point of intersection means they have the same x, same y, and since this is in 3D, they will have the same z for both my line 1, let's say line L and line M, right? So that's where I'm going to start from, okay? So now, which means I am only going to look at my x component. I'm going to look at my x component of my line 1, and that will be equal to the x component of my line 2, right? I'll do the same thing for my y. I'll look at my y component of my line 1, and I'll compare that with the y component of my line 2, and same thing for my z component of line 1. Compare that with the z component of my line 2. All right, so that's kind of the overall picture of what I'm going to do next. Okay, so I'll have the x component. I will have 3 plus s multiplied by 1 is going to equal to 6 plus t times 0. 6 plus, so on the left hand side I have 3 plus s is equal to t times 0 gives me 0. I'm gonna have 6 here, so my s is equal to 3. Okay, and so we have just found the s value that will make my x component of line 1 the same as the x component of my line 2. Okay, so let's see if the s value actually makes sense. Now I'm going to verify with my y component with the s is equal to 3. So I'm going to have 0 plus s times, sorry, my s is 3 now. This is my 3 times 1. Is this equal to the y component of my line 2? So this is 2 plus t multiplied by 4. Right? So let's say, so this is 3 plus 0 plus 3, that gives us 3 is equal to 2. So this is 2 plus 4t. So move the 2 over, I have 1 is equal to 4t. So my t is equal to 1/4. Alright, so if my s is equal to 3, my t is equal to 1/4. Now, there's one more component that I have not analyzed, which is my z component. So let's see that. So the z component of my line 1, which is -1 plus my s is equal to 3, right? So s times, sorry, my s is 3. This is 3 multiplied by 1 is equal to 0 plus, again, no, we just found our t. Our t is 1/4. So this is 1/4. 1/4 multiplied by 8. Is this true? We'll see. -1 plus 3 is equal to, this is 1/4 times 8. That gives us 2. So this is 2 is equal to 2. So that's okay. This is good. All right. So these two line R1, sorry, but vector R1 and my vector R2, they will intersect when s is equal to 3 and t is equal to 1/4, right? But now they're asking, where is that point of intersection gonna be? What are the coordinates of that point? So I'm just going to use either one of them to find out where that point is. So I'm gonna, let's say if I choose to go with R1, if I choose to go with R1, then I will have 3, 0, 1. Sorry, it's 3, 0, -1 plus my s is 3. 3 multiplied by 1, 1, 1. And that will give us 3 plus 3, that's 6. 0 plus 3, that's 3. -1 plus 3, that's 2. Right? So this is the point of intersection. This is the point of intersection. All right? Okay, so if I use R2, right? If I use R2, my t is equal to 1/4, but I am expecting the point to be the same, right? So let's try that. So I'll have 6, 2, 0, plus my t is 1/4, multiplied by 0, 4, 8. And let's see. So 6 plus 1/4 times 0, that's still going to be 6. 2 plus 1/4 times 4, that's going to be 1. So 2 plus 1 gives us 3. 0 plus 1/4 times 8, so that's 2. This is 2. So as you can see, they will give us the same result. All right? And that makes sense because the point of intersection is where these two vectors have this have the same point in terms of the x, y, and z coordinates. All right? Okay, I hope you guys found this video helpful, and I'll see you in the next video. Bye bye.